got to mention something important about the fins. So let me write it now. Okay. So remember that the fins, the CN. Well, let's just do it in the middle. All right. Okay. The CN of the fins, it was practically linear. So this means that if we take the derivative, or linear in function of alpha, of course, with the angle of attack. So if we take the derivative of Cn of the fins, it's going to be practically constant and equal to pi aspect ratio over 2. You can check that for yourself. The sinus square term drops. Oh, sorry, I'm missing. Yeah, I'm missing this surface over A. Yeah, the sine square term drops. Let me do this. Around. This is the derivative of CNF around alpha equals 0. Okay, so this is like the Taylor expansion. It would be the Maclaurin series because it's around alpha equals 0. So this is, you saw that the graphic, it was practically constant. So what we have is, if this is the Mach number and this is the Cn of the fins. Oh, that's a bad line. I'll try to do it. I still gotta get used to this. Okay, so remember that Mach number that in which the Cn of the fins changed? It was this. We'll just call it Mach sub L. So up to Mach sub L, it's linear. This is the derivative. Okay. So in this area, we can approximate Cn of the fins is approximately the derivative around 0, because we always have small angles of attack, times alpha. So if we plot this up to Mach sub L, it's going to be constant. It's this number. But what happens when we get Mach numbers above Mach sub L? Well, the derivative is going to be let's see if I get it right. The derivative of the Cn of the fins on Mach numbers over Mach sub L is now going to be 4 times this part, which is function of the Mach number, times S surface A. Okay, so if you plot this in function of Mach, you're going to see that when you reach this certain Mach number, well, the fins are gonna do way less restoring normal force. So you got to get that in mind. Keep that in mind. You're gonna see which effects this has, mostly in the maximum angle of attack the rocket can have at these speeds, and probably most importantly, it affects a lot the it affects a lot pitch roll coupling, so resonance. We're going to see that. We're going to see that in further videos. So I might as well stop the video here and start a new one. I'm just going to change this to a better title. Aerodynamics of the fins, part 2. And now in the following video we're going to see the aerodynamics of the nose cone and the body.